Good evening, ma'am. Your voice is very low.
My voice is very low. Let me check.
Ma'am, now okay.
Now it's fine. Okay. All right. So today we have solve with a session for week 11. I will present the slides for that.
Ma'am,
Yes.
ma'am, after the session, can we ask a question from previous graded assignment?
Which graded assignment? Previous?
Ma'am, previous week graded assignment. That is week 10, ma'am.
Week 10. Okay. If there is time, yeah, we can do it.
Ma'am, because as per my answer, ma'am, they have provided the wrong, answer, ma'am. But when I calculated, my answer is correct, ma'am.
Okay. Okay, we'll discuss. We'll discuss.
Ma'am, what is the code?
Hold on. I'll present the screen.
Ma'am, one more complaint I have, ma'am. Hello.
Ma'am, your voice is lagging.
You're not able to hear me?
Ma'am, now
Hello, Nikita.
Yes.
Yeah, we can hear you, but there is some break in between your audio.
Okay.
Maybe network issue, I think.
Okay. Let me check.
Yeah, okay.
Okay, so I see 5 of you have joined. So let me start the class. So for the people who have not joined in yet, please go to joinpd.com and use the code that you can see on the top over here. That is YBR XMF. Are you able to see the screen?
Yes, ma'am.
Yeah. Maybe we can wait for 1 more minute so that more students join, and then we can start.
Ma'am, meanwhile, can I ask that question, ma'am, to you?
Yes.
So, ma'am, I was asking about the graded assignment, ma'am. Question number 9, ma'am.
Graded assignment question number 9. And there was one more query that you had.
Yeah, another queries, ma'am. In my dashboard, ma'am. I mean, it is showing, ma'am, in activity question like week 1 activity, week 2 activity, absent showing, ma'am. But I have attended all the week 1 activity questions.
Okay.
Ma'am, that is for extra activity, ma'am.
Okay, extra activity. So extra activity, if you have done, but did you review 3 people activities? I don't know who was asking. Did you review the activities of other students?
No, ma'am, I'm just seeing my dashboard, ma'am.
No. So like it is mandatory that apart from you just doing the activity, you should also review, I think, 3 students' activity, right? If I'm not
Yes, ma'am.
That I
Then
didn't do.
that is why you didn't get the marks.
Okay.
Yeah. So it is mandatory for you to review at least 3 students' activities.
Okay, ma'am. Got it.
Okay. And if we go to graded assignment week 10, to question number 9, you said, right?
Yes, ma'am.
Okay.
Ma'am, can I dictate the numbers, ma'am?
Hold on, I'm just looking at it. Okay. The question is about x being a random variable with the following probability distribution. This is the question.
Yes, ma'am. This is the question.
You had to find the expected value of 2x plus 1 whole square.
Yes, ma'am.
How did you solve it?
Ma'am, first, ma'am, actually, uh, uh,
Sorry, if you're speaking, I'm not able to hear you.
just a second, ma'am. Now I'm opening my Notebook, ma'am.
Okay. Okay. In the meantime, let's start. Maybe we can discuss it later. So I hope you all know how to use spear deck.
Yes, ma'am.
Okay. So the first question that we have over here is you have 3 experiments that are given to you. So in the first experiment, you're tossing an unbiased coin 100 times and counting the number of heads that appears. Okay. In the second question, you are tossing a biased coin for 100 times and counting the number of heads that appears. Okay. And in the third part, you are choosing 5 balls randomly from an urn that contains 20 yellow balls and 20 red balls without replacement and counting the number of red balls chosen. Okay. So which of these, which among these 3 experiment do you think is not a binomial experiment?
Ma'am, third one is not a binomial experiment.
Okay. And why is that? Why is the third one not a binomial experiment?
Because, ma'am, in the binomial experiment, all trials are independent, not dependent.
Okay. But here, why do you think it is dependent?
Ma'am, in third statement, it was given that it's doing by without replacement. In binomial distribution, we do with the case with the replacement.
Yes. Okay. So yeah, that's a difference over here. So in binomial, we always take care that for each trial, we repeat the experiment by replacing whatever outcome we get, right? Whatever observations we get. So we keep on, the experiment will be performed based on will be with replacement and not without replacement. Okay. If you look at the first option, you see. Okay, so almost all of you have answered option C. So that is good. I'm sure it is clear. So the first one, tossing an unbiased coin for 100 times. So you're repeating the experiment 100 times and you're doing it independently because every time you repeat the experiment, outcome on your current toss is not going to depend the outcome of your next toss or so on, right? So you are and you're repeating the experiment and you're counting the number of heads that you get. So that is nothing but if we say that my success is number of heads, so yes, this is a this is nothing but a binomial experiment. The second one again it's saying the same thing, but the only difference is in the first case we had said we are tossing an unbiased coin, but in the second case we are saying we are tossing a biased coin, right? So that's the only difference. Otherwise it doesn't make any there is no major difference between the first and the second one. It's just the biasness and unbiasedness of a coin, and that doesn't affect our probability of success. So again, it models the same reason that it models a binomial experiment. And the third one, like the only problem over here is that we are saying it is without replacement. If it was with a replacement, then yes, it was also a binomial experiment. Okay. Let's move to the second question. Okay. So in the second question, it says there is an archery trainer who wants to test, like some new students have joined in, and the trainer wants to test their archery skills, which so like in the newly joined students, there are also some prodigies. Prodigies are like the who are quite skilled or talented in archery, right? So the trainer basically wants to test the archery skills of these newly joined students. Now, what does the trainer does? It's the trainer put up a circular board. So imagine a circular disc that is there, and it is of radius 20 meters. So if the student shoots an arrow in the region of radius 5 meter, right? So you have a circle. Now you make another circle, like two concentric circles you have. So one of 20 meters radius, other of 5 meter radius, right? So if the student shoots an arrow in this region of radius 5 meters, then whatever trial it is considered as success. Okay.
Ma'am,
Yeah.
your voice is breaking.
My voice is breaking. It's breaking a lot.
Yes, ma'am.
Okay, then just give me 1 minute. Maybe not one, maybe 2-3 minutes. Just wait. I will rejoin. Is it better now? Can you hear me?
Yes, sir.
Okay. So I already see you have 5 of you have done the question. So I hope the question what
Ma'am, your voice is still breaking.
uh, okay, just 1 minute, okay. Are you able to hear me now?
Yes, ma'am.
Yeah. Um, all right. Okay, I see some 6 responses. Any doubt, anybody? So the range of answers are varies a lot. Um, okay. So here like you had to, like there was a circular disc which is of 20 meter, right? And only if a student shoots the within the radius of 5 meter, it is considered a success. Okay, and the student has to take 3 trials, and only if the student clears at least 2 trials, then the student passed the test, right? So you have to find the probability that the student will pass the test. So what are the cases that are possible in this? Anyone? What is it that we have to find here? Are you able to hear me? Yes, no.
Yes, ma'am.
Okay. So what is the random variable here? Like what exactly it is that you have to find? You have to find the probability that a normal student passes the test. Okay. So if I say define a random variable x as the number of, we have to find probability that a student passes the test. And it is given that only if out of 3 trials, a student clears at least 2 trials. So at least the student gets 2 successes out of the 3 trials, then the student passes the test. Right?
Yes, ma'am.
So my random variable, I can define it as number of tests that are required to pass the test. And since we have to find the probability that the student passes the test, so what we have to find is probability that x is greater than equal to 2.
Yes, ma'am.
Right? So, and how many trials do we have? We have 3 trials, right? So number of trials that in this case is 3. So n is 3. You have to find probability x greater than equal to 2. So that would be probability of x equal to 2 plus probability x equal 3. Right?
Here, what is the probability of success?
Yeah, what is the probability of success here? That's the question. So look at this sentence. It says if a student shoots an arrow in a region of radius 5 meter, then you consider the trial as a success. Right?
Yes, ma'am.
Now imagine a circular disc that is of 20 meter. You have another circular disc of 5 meter. So like think of it as 2 concentric circles. So one of 5 meter radius, other of 20 meter radius. Now only if your target you shoot an arrow in the radius of 5 meter, you have a success. Okay. So the probability can also be seen as like the area that your 5 meter radius board covers divided by the area that your total disc covered of 20 meter. Right? So look over here. So what is a random experiment? How did we define the random experiment? We define the random experiment as shooting an arrow on the circular board. Okay. Binomial experiment is getting a success in throwing an arrow onto the region of radius less than 5 meter. Otherwise, it is a failure. And the probability that arrow will land in a particular region, that will be directly proportional to the area of that region, right? So the area of the region that we are interested in for the success is pi times 5 square. That is 25 pi, right? And the total area is what? Total area of the board is 20 square pi. So that is 400 pi. So probability of success would be like whatever area that my success, the circular board of 5 meter covered, divided by the area that, divided by the total area, right? This is how like the general notion of probability works. Right?
Yes, ma'am.
So this is how we find the probability of success. Now we have the probability of success and we need to find probability that x equal to and probability x equal 3. Right? So what will be probability of x equal to 2? How will you find probability of x equal to 2?
And see I into probability p of I 1 minus p and 1 minus.
Yeah, right. So now we know that it models your binomial variable. We know the total number of trials. We know the probability of success. So we can easily find out probability x equal to 2 and probability x equal 3. So you just have to use the formula. And your answer would be 0.011. So if I go back, and now I see the answers have shifted. Okay.
Ma'am,
Yes, tell me.
what does the last statement in the question mean? Probability has equal chance at anywhere on the board.
The last sentence, probability of passing the test.
No, in the question it is given.
What is the probability that a normal student pass the test?
Assume for a normal student there is equal chance that the row will land anywhere on the.
Okay.
How to interpret it?
So, I mean, when you are asked to shoot an arrow, I mean, like this assumption have been made that uniformly this can land anywhere on the board. So this whole 20-meter board, it can land anywhere. And that is why we are able to use this this thing, this finding the probability of success in this way.
Okay, ma'am.
Okay. All right. So we have the third question, and it says, suppose you have you're tossing a biased coin, and the variance and expectation of getting number of tails in tossing that coin is given to you as 1.05 and 3.5. So the variance is 1.05 and expectation is 3.5. Now, what you have to find is the probability of getting 3 tails.
Ma'am, we are tossing only one coin.
We are tossing?
Only one coin.
No, I mean, we are tossing a biased coin like many times. And that is why we are able to find variance and expectation. So you have a biased coin, you are tossing it repeatedly, and what you got is you got the variance of the number of tails in all the tosses is 1.05 and the expectation is 3.5. So now you have to find probability of getting 3 tails.
They haven't given how many trials?
Exactly. So to find the number of trials, you will have to use the information of the variance and expectation over here. But to even go there to find that number of trials, you need to understand first thing that what kind of experiment is this?
Hypergeometric, ma'am.
Hypergeometric? Yeah, you already know what is the expectation and variance of all the random variables that you have studied. So what is
So in more,
Binomial. Can it be binomial also? No.
ma'am, how we can identify its binomial hypergeometric if question was given like that?
okay? So see here your just one coin is given to you. Oh, and they are saying it is a biased coin, right? So you are repeating it, you're tossing it repeatedly. Now, what you have to find the probability of getting 3 tails. So you need to define and what is given to you, the variance and expectation of getting number of tails is given to you. Okay, so we can define a random variable x as number of tails that you get. Just number of tails, we can, let's say in any n number of trials, okay, number of tails. And from the lectures, we have seen that such kind of experiment are modeled as a binomial random variable, right? Because here it is not without replacement, it is with replacement case, such cases, right? Because every time the coin you're tossing is same. Right? So if we define the random variable x as number of tails in some n number of trials, then from there we know what is the variance of my binomial random variable. What is the expectation of my binomial random variable? We solve for that, and we need to know the first thing is what should my n be, and apart from that, I should also know what is going to be my probability of success because it is a biased coin, right? So work it out. I will give you some time. Okay, I see 4 different answers here. Do you need more time to solve for this question?
Ma'am, one more.
I'll give 1 more minute. Just think about it, because there are many different answers that I have given. All right, let's discuss the solution for this. So as we discussed, this is a binomial experiment, and we are going to define our random variable as number of tails that we observed. So what is a variance? What is expected value and variance of a random variable, of a binomial random variable? What is the expectation of a binomial random variable?
Ma'am, expectation is NP and variance is NP into 1 minus P.
Okay, and you are already given what your NP is and what your n times P times 1 minus P is, right? So we go ahead, substitute it, and solve for these 2 equations that you can see on the bottom. So we solve for these 2 equations, and what we get is P equal 0.7 and N equal 5. So is it the same P and N that you got?
Ma'am, I got M is 1.5.
What did you get?
M is 1.5.
N is 1.5. N cannot be 1.5, no? What is the value of P that you got?
Ma'am, 0.7.
Okay, so if I have P equal 0.7 and I substitute it, let's say, in the first equation that we have. So P equal 0.7. So 0.7 times N equal 3.5. N equal 5, right? Not 1.5.
Yes, ma'am.
Yeah. So when you solve these 2 equations, you will get P equal 0.7 and N equal 5. And now since we know what is my P and what is my N, then we can easily find out the probability of X equal 3, right? So we just use the formula for the PMF of a binomial random variable, and we get the answer as 0.3087. So this is the correct answer. So the people who have given the answer as 0.13, 0.422, 0.46, just look at your solutions. Where are you going wrong?
Ma'am, I do for P, I find P is correct, but N is wrong.
Yeah, so even if one is wrong, you're going to get the wrong answer. And think about it, like n cannot be 1.5. N is a natural number, right? N is the
Yes.
number of trials cannot be 1.5.
Yes, ma'am.
Yeah. So just take care of these mistakes. Okay, we'll move to the next problem. Okay. So here you have again a coin toss experiment, and let's say you are given a coin and you have to test whether this coin is fair or not. So what you're going to do to test this is you're going to keep on repeating this coin again and again. So you are so instead of repeating it again, you are just tossing it 4 times. Okay. And the binomial random variable x is defined as the number of total heads that you get after the 4 tosses. Okay. So the question is, what is the probability of getting a head? So what exactly do you have to find here?
Probability of that.
Probability of head. But how is your random variable defined? It is defined as total number of heads in 4 tosses. So depending on what you are going to consider as a success or failure, I mean, okay, you first decide what you're going to take as a success. I'll give you some time. And the PMF for this binomial random variable is already given to you. You already know what is n, but you don't know what your p is. So using this information that n equal 4 and the PMF of this random variable x, you have to find p. Okay. Again, we have 3 different answers for this question. So how will I find the probability of getting ahead over here? Do we consider getting ahead as a success, or should we consider it as a failure?
Ma'am,
Success. Okay. So how do we find the probability?
ma'am, I can do by finding probability of getting low and
See, we know that my number of trials is 4. That is given to us. It is given to us that probability of x equal 1, what is probability of x equal 0, what is probability of x equal 1, x equal 2, x equal 3, and x equal 4. So we can use these probabilities and you can use this probability and we can find RP, right? So let's say if we take probability of x equal 4. Okay. So why we have chosen x equal 4 and x equal 0? It's just because the calculation is quite easy. You can pick any one and you can try solving for it. So if you take probability x equal 4, so we know that since x follows the binomial random variable, it should be n choose k, so 4 choose 4, p to the power 4, 1 minus p to the power 4 minus 4. And that is given to us as 0.0256. All right. So from here, we can find p to be 0.0256 to the power 1 by 4. Right?
No,
yes, ma'am.
exact answer is 0.48.
Sorry.
Ma'am, answer is 0.4.
0.48, ma'am.
0.48. Yeah,
Ma'am,
it was somewhere in the neighborhood of this 0.4.
ma'am, I get 0.4.
Yeah, so somewhere in the close. So solving this, we got p squared to be 0.16. So p is just 0.4, right?
Yes, ma'am.
It should be the nth root of, fifth root of that
Not
fifth
fifth,
value, right?
not fifth, the fourth, right? I mean, p to the power 4, you're solving for p to the power 4 to be 0.0256.
Oh, yeah, yes, ma'am.
Not the fifth root. So you pick any one of it and pick any of the probabilities and you can solve for p. And since all these probabilities that are given to you here in the PMF table, this has been calculated considering that my head number of getting number of heads is a success. So that is why when we are finding the probability of getting ahead, we are considering it as success.
Ma'am, answer for this question is 0.4.
0. Yeah, 0.4.
Yes, 0.4.
So there is another way also that in which you can solve this problem. So you know already that it is a binomial random variable, and you know how to find the expected value of a binomial random variable. You know the formula. And even if you don't know the formula, the PMF table is given to you. From there, you can find the expectation. So if you just equate, solve for both these two and equate it, you should easily get your p-value. But I would say the previous method is much easier.
Okay.
Okay, let's move to the next problem. So again, you have a binomial random variable. The number of trials is 8, and the variance of the random variable is given to be 1.92. You have to find what are the values that are possible for P. And if more than 2 values are possible, you write both the values. Okay, so in this question, we had to find the values that my probability of success can take, right? And since it is a binomial random variable, we know that the variance would be n times p times 1 minus p. N is given to us, and p is what we have to find. So, and the variance is also given. So, like you just substitute it, and you should be able to get There's a question over here. That is p times p minus p square equal 0.24. And solving this, you will get 0.6 and 0.4. So both are the both values of p are possible. So we'll just write 0.6 and 0.4. This question is clear to everyone?
Yes, ma'am.
Okay. So this is our second last question. Here, in this question, what is being given is you have a box where there are 10 chocolates. And if you draw 2 chocolates at random without replacement, okay? It is not with replacement, but without replacement. So you're drawing 2 chocolates and you have to find out the expected number of dark chocolates that you have drawn. So the first thing is you should identify what distribution does it follow. And then depending on the distribution, you know, like what is the expected number. Okay. So before we proceed for a solution, can someone tell me what kind of distribution does it follow?
Ma'am, it follow hypergeometric distribution.
Hypergeometric distribution, right? Okay. And what is expected number of what is the expectation in case of hypergeometric of a
Ma'am,
hypergeometric?
small n into m divide by capital N.
Okay. All right. So see. In the question, we have to find the expected number of dark chocolate strawn. Okay. So we can define a random variable x as the number of dark chocolate strawn from the box, right? So from there, since we already know that this random variable follows our hypergeometric distribution, and we know its expected value is given by this m times n divided by capital N. So what is this m, or like small m? What is small m? So m is like whatever. So in this case, in your case, we are interested in finding the expected number of dark chocolate strawn. So that is what we can take as m, and n would be number of n is what in this case? You are selecting
Ma'am, we are selecting 2 chocolates.
two. Yeah, you're drawing 2 chocolates, right? So out of 10, so n is your capital N is your total. So out of these 10, you're drawing a sample of size 2, right? Because you're picking 2 chocolates from there. So out of a sample of size capital N equal 10, you are drawing a sample of size small n equal 2. Okay, so in our case, my n is 2, capital N is 10, and m is 4. Right? So from there, we can easily find the expected value of x. So here, it's very simple. It just you have to understand, looking at the question, you should be able to figure out like what distribution does it model. And once you are able to identify it correctly, and you know like what are the expected value of what is expected value of that distribution, you can easily pick out like substitute the values and get the answer.
Okay.
Yeah. Okay. So now we have the last problem for today. Okay. So this is Poisson distribution. So here it says, suppose a car hired farm has 2 cars, which it hires out day by day. Now the number of cars, the number of demands for any car on a particular day is distributed as a Poisson random variable whose mean is given as 1.5. So you have to find the proportion of days on which neither car is used. So for a Poisson random variable, what is the mean? What is the mean? Let's say I'm saying my random variable x follows Poisson lambda. So what is the mean of this Poisson random variable?
Ma'am, for Poisson distribution of average mean is lambda.
Okay, yeah, average is lambda. So you will have to use that information to find the answer. I'll give you some time and then we can get back to this. Okay. All right. In this question, how are you going to define the random variable? The question that you have to find out, the answer you have to find out is the proportion of days on which neither card is used. So how do you define your random variable here, looking at this question?
The random variable can say 0 when there is no car used, 1 when there is when one car is used on a day, and 2 when 2 cars are used.
Yeah, so number of cars that is there in the demand for each day. So that is how we can define it. And okay, and we already know that the demand for a car on each day is has a mean of 1.5. So lambda, we know it is 1.5. And what we have to find out is the proportion of days on which neither car is used. So probability where the number of cars used is 0. So basically the demand is 0, right? So we already know that if your random variable follows a Poisson random variable with the parameter lambda, then its probability is given by e to the power minus lambda to the power x by x factorial. Now, in our case, we need to find out the probability when none of the card is used. So basically the demand is 0. So my x in this case is 0. So and x is 0, and we already know that mean is given as 1.5. So lambda is my 1.5. So we just substitute these two values as x equals 0 and lambda equal 1.5, and we should be able to get the answer.
Yes, ma'am. Ma'am, I got 0.224.
Okay, I mean, after 2 decimal, it is okay. So whoever has answered this is correct. But the people who have answered 0.251, maybe 0.251, there's slight mistake you would have done. It's quite close, but 0.312 0.049 is wrong. Just look at your calculation, or maybe the way you have approached the question might be incorrect. And that is why you're getting such extreme answers over here.
Ma'am, 0.224 is correct or wrong?
That is correct. .224 is correct.
Okay.
Okay. So this was our last question for today. Any doubt so far in any of the questions? Any of the questions that we discussed? Anybody has any doubt?
Ma'am, can I ask the same question?
What you had asked earlier, right?
Yeah, ma'am.
Yeah, sure. I will just stop presenting this. Yes, tell me.
Yeah, ma'am. The graded assignment.
Yeah. So the question was to find expected value of 2x plus 1 whole square, right?
Yes, ma'am.
So how did you approach that problem?
Ma'am, first of all, I have solved this one. I mean, expanded this one through algebraic expression.
Okay.
That
4x square plus 1 plus
yeah,
4x.
yeah, 2x. If you apply the formula of a square plus 2ic b plus b square, then we can we take 2x as a and 1 as a b.
I mean,
Then
we'll
we
get expected value
solve
of 4x square plus 1 plus 4x.
4x, correct.
right? So this will become my 4 times expected value of x square plus expected value of 1, which is nothing but 1,
1
plus 4 times expected value of x.
x, correct.
So we need to find two expectations over here. So one is expected value of x, other is expected value of x square,
X square, yes.
right?
Yes,
So
ma'am.
to find the expected value of x, what will you do?
Expected value of x, ma'am. You're talking about, or x square.
Yeah. No,
Yeah.
x. How will you find expected value of x?
Yeah, so we consider this. We take values from the table. So table in table in x, whatever is that number is given, we multiply that with probability of the next
We
value,
do,
and
it's
then
sum over.
add all of them.
Yeah, so that will give you expected value of x.
X,
Now,
correct.
how will you find expected value of x square?
We have squared all the values.
Square which values?
That means that -1 into 1 by 6, square it, and then after that and add, and then again 4 by
Correct.
yeah.
Correct. Yeah. I mean, instead of doing x times px, now we will do x square times px.
Px, yes, ma'am.
Yeah. So from there you will get expected value of x square.
Yes.
So now we just substitute and we get the answer, right?
Yes, ma'am.
So what is
So
happening?
my answer is coming, ma'am, 41, ma'am, after calculating that. And
Your answer?
yeah, 41, and they are giving 87.6 range from 87.64 to 87.7.
Okay. Let me see.
Ma'am, can you calculate, ma'am, please?
Yes. Hold on. So one thing is maybe the questions are parameterized. That is one thing that can happen, and that is why the range varies. Hold on. Let me see if the question I have is the question you somehow.
Let me dictate the table number in the table, ma'am. Because
So
your
for
table
me,
may be different from my table, ma'am.
Yeah, so for my table, my x takes the value -2, 2, 6.
No, -1, 4, 4, 5.
-1, 4, 5 for you.
Yes, ma'am.
Okay, let me share my screen and maybe we can solve this.
Yes, yes, ma'am.
Please tell me the table that you have. What are the values you might say?
Yeah, ma'am. First one is -1.
Okay.
X values are -1, 4, and 5.
Okay, and what are the probabilities?
Yeah, probability values are 1 by 6,
Okay.
1 by 3,
1 by 3,
and 9 by 18.
9 by
18, 1, 8, 18.
18, okay. So expected value of 2x plus 1 whole square is expected value of 4x square.
4x square plus 4x plus 1.
Now this would be 4 times expected value of x square.
Yes.
plus 4 times expected value of x. So now we find expected value of x.
This one.
Of x is minus 1 by 6 plus 4 by 3 plus this is nothing but 1 by 2. So by 2. This is 5 by 2. And this is what? This is 6 minus 1 plus 3 2 just 8 plus 3 15.
This is going to be 31 by 18.
This is 14 plus 8. 14 plus 8 is 22 by 6. Is this right? This is fine, no?
It will be coming right. My values are coming 4 into 149 by 18 plus 4 into 31 by 18 plus 1.
4 into
149. I mean square. If I take the square, then 149 by 18.
No. I'm finding expected value of x.
Yeah, expected. Oh, sorry. Expected value of x is 4 into 31 by 18.
4 into 31 by 18.
This one.
So this is what? Wait. So if I multiply it by 3, it is 66 by 18. This is what it should come. And we are getting 124 by 18. Oh, there's a huge difference. Wait. So
Minus 1 by 6, ma'am, plus 4 by 3 plus 5 by 9, right?
5 by 2, no? 9 by 18 is 1 by 2.
No,
18, right? 9 by 18, I wrote it as 1 by 2.
we have to multiply this by this, right? 5 by 9, right?
5 by 9. No, I mean, I have just simplified it, no? 9 by 18, I wrote it as 1 by 2.
1 by 2, huh?
So now minus 1 times 1 by 6, which is minus 1 by 6. 4 times 1 by 3, which is 4 by 3. Plus 5 times 1 by 2, which is 5 by 2.
Okay, got it, ma'am.
Yeah. So this is what we get. So maybe you can recalculate expected value of x square also.
Yeah, got it, ma'am. Right, I got it. My where did I do the mistake, ma'am?
Yeah, you got it, no? Okay. Yeah.
Actually, I have taken 5 by 9.
Yeah, there you're making the mistake. Yeah.
Okay, thank you, ma'am.
Okay, yeah, thank you.
Ma'am, I have a doubt in the 10th grader 17 question.
Question number?
Ma'am, question number 6.
Question number 5.
Ma'am, question number 6.
Question number 6, okay. I think we have discussed this question. We discussed this question today, is it? Yeah. I mean, kind of, okay. Tell me, what is your doubt?
Ma'am, I got 0.81, but the range is 1.18.
You got?
Ma'am, I got answer for that 0.81 and the answer is 1.18.
Okay. Okay, maybe it is not similar to what I see the question as, but okay.
Ma'am?
Yes.
Ma'am, but the answer provided by
it will be parameterized.
Yeah, answer provided by them, ma'am. It is given. They have given through the formula. like a square plus 1 by d and all that stuff, right? So if we take f, ma'am, then f will be 1 by 3, 5 by uh, uh, 5 by 9, right, ma'am?
Not 5 by 9. It is 9 by 18, right?
1 by f, ma'am. If you see the solutions provided by them, ma'am,
Okay.
even that makes me like,
See, even if you look at the solution document, now to find the expected value of x, what you should do? You should take the value of x and multiply it by its probability. So a times 1 by d plus b times 1 by e plus c times 1 by f. That is all. If I
yeah,
have to
c times 1 by f. So they have
Yes.
taken f divided by g, right, ma'am? Then f would be
Okay.
5, right, ma'am?
Okay. But all right. Yeah, I get your point.
Are you getting it, ma'am? What I am just trying to say, ma'am?
Yes,
Because f
yes.
by g, they have written f by g. So if they have written f by g, so that means 5 by 9. So f should be 5, right? So in that case, 1 by it should be 1 by 5, right?
Maybe there's a mistake there, but you didn't get this question right. You got specific values of a and specific values of probabilities.
But even like if I take 1 by 9, 5 by 9, the answer is not coming 87.5.
Why will you get 5 by 9? I mean, you had
Sorry, not 5 by 9, 1 by 5. Sorry, 1 by 2. That means 5 by 2, right?
5 by 2.
Yeah, I'm not getting, even then I am not getting, ma'am, 87 by 5.
Okay, so okay, let me just complete the solution that where we left.
Okay, ma'am.
Um, so this is correct, what we did.
Hmm.
Now, you're able to see my screen. So x squared is what? X squared is 1. So 1 times 1 by 6, which is 1 by 6, plus 16, right? 16 by 3
Yes, ma'am.
plus 25 by 2. Right? Now, this is going to be 1 plus 32.
32
5.
plus 75.
Will be 5, 6, 7, 8, 7, 8, 9, 10 by 6. Now, from here, what will I get? I will get 4 times
4 times 108 by 6
1
plus
4
1
times 6 by 18.
22 by 6. Sorry, 66 by 80.
Right? Maybe I can simplify it. So 2, this is 3, this is 3, 6, 4, this is 2, and this is 9. This is again 3, and this is 22. It doesn't get cancelled, okay? So 6 to 12, 72 plus 1, which is 73, plus 44 by 3. I think we should get somewhere between 80. So this is what? This is 12 point something, right? I think 12.3. 313, 12, 6, I think. Okay, something. If you add 73 to it, I mean, you will get somewhere 86, in the neighborhood of 86. And I think that was the range that was given to you.
No, ma'am. The range is 87.6 to 87 point something.
What is the range given?
87.64 to 87.7.
87.46.
64. 87.64 to 87.7.
87.7. Okay. They're saying this is the range given. All right. I think this is range. Are you sure this is the range given? Because this
Yes, ma'am.
range is very small.
Yes, ma'am. That is the reason. Like I'm totally confused
Oh,
of the
but
answer.
we did the right calculation. I don't think we have made a mistake. 612 plus 2, 375. 5, 6, 7, 8, 10. This is fine. So 4 times 108 by 6 plus 1 plus 4 times 66 by 18. 14 plus 8, which is 22 by 6. Fine. 2, 3, 3, 3, 9, 6, 18, plus 72, plus 1, 73, 2, 9, 3, 2, 44 by 3. Yeah, I don't know.
Ma'am, could you please show one's PMF for this?
Sorry.
Ma'am, could you please show table for this question once?
Okay, I mean 44 by 3 is no, it will come. Okay, 44 by 3 is 14.66. Now if I add 73 to it, I get 87.66. So it's correct. I mean, it's not wrong.
Yes, ma'am. Yes, ma'am. Got it.
Yeah. Okay.
Yes, yes, ma'am.
Yeah.
Now it's coming right.
Okay. Okay. So somebody was asking question number 6.
But ma'am, actually, the solution.
I think the solution document is randomized, so you get all the parameters instead of numbers.
Ma'am, I faced the question.
Question number 6, right?
Yes, ma'am.
Okay. The question that I have is, in a box there are 7 white and 8 black balls. 2 balls are drawn at random without replacement. Find the expected value of the number of white balls drawn.
Ma'am, I faced the question.
Pasted the question. Yeah, I mean, just a different parameter. Okay. So 10 times 2, 20 by 18. What is the answer that you're getting?
Ma'am, I got 0.81.
You got what?
0.81.
0.81. And what is the range that is given? What is
Ma'am,
the range?
that is 1.08 to 1.12.
1.14. Okay, so my answer comes in the range. Okay. Just now we discussed, I mean, in Solve With Us, we discussed a problem of this kind, where instead of balls, you had just candies. Just apply the formula, you will get the answer. Because from this question, you can see that it is a kind of hypergeometric distribution. And just pick out, and in this case, my small m is 10, small n is 18, and capital N is 18 and small n is 2, because we're drawing 2 balls. And we're interested in finding out the expected value of number of white balls. And in your question, number of white balls is 10. So we took m to be 10.
Okay.
Yeah. Okay. Anything else? Okay, then we can close the session for today then, and we'll meet again in the next.
Hello, excuse me, ma'am.
Yes, tell me.
Yes, actually, I just had a little operational problem. Can you please check the week 11 graded assignment first question? I think the options are in the syntax is not correct.
Yes, ma'am. Even I had the same issue.
Yes, ma'am.
Okay, okay. Let me see. Wait.
And ma'am, in one more question.
Okay. Yeah, it is okay. We'll
One more question also in graded assignment, the option is given like this, like not clear.
Yes,
question.
ma'am.
Question.
Okay, 9. Question number 9. Okay, we can correct it and maybe it will be updated. So for the first question, like sum of, you can think of it as like the option as a summation I varying from 1 to 2. 4 choose I. Okay, I think there is some issue. Okay, we'll get it corrected and maybe we should be able to did it properly.
Ma'am, deadline is today for that. Ma'am, deadline is today for week 11 graded assignment.
I'm not able to hear. Can you repeat?
Ma'am, deadline for week 11 is today.
Deadline for week 11 is today. We'll get it resolved as quickly as possible. We'll do it in half an hour or so.
Okay.
Yeah.
Are
Okay.
you planning to like extend the deadline, ma'am?
No, deadline will not be extended. I think the deadline is today. Yeah, it is today.
Okay, ma'am.
Okay. Okay, we'll get it resolved as quickly as possible and you can work on these problems. All right then. Anything else? Okay, if there is nothing, we can close for today. All right.
Thank you, ma'am.
Yeah, thank you. Thank you all.
Thank you, ma'am.